Hello friends. Today I'll be just giving a lecture or a presentation on the introduction to design of steel structures, and this will be the part 1. Uh, in this part 1 we'll be dealing with the properties of the steel, structural steel, and the stress strain curve of the mild steel, structural steel products, and the choice of the section. So these are the parts will be discussed today. So as I said, coming to the properties of the steel. So steel structures is one of the major important structures in the civil engineering, as we people know, which we have been studying. And here I have listed some of the properties of the steel. Properties of this steel have made three comparisons. One is the cast iron, wrought iron, and the steel. Okay, so here I have listed some of the properties which you can go through. Firstly, I have told with the composition, and coming to the composition, crude form of iron which contains about 2.5 to 4 points of carbon in cast iron, and wrought iron, it is a purest form of iron, contains around only 0.2% of carbon. And coming to the steel which we use, it is a midway. It is steel is a midway between cast iron and wrought iron, and it contains of about zero point 0.1 to 1.1% of carbon. And coming to the structure of the steel, how it is. Cast iron is crystalline and wrought iron is fibrous in nature, and steel is granular structure. And here I have listed some of the properties of like specific gravity, melting point, and the ultimate compressive strength, which is one of the most important property which we can say. It is 600 to 700 MPa for cast iron. Wrought iron it is 200 MPa, and for steel it is 180 to 350 MPa. And also coming to the tensile strength, which is also one another important property. Here I have listed the values: 120 to 150 MPa, 400 MPa for wrought iron, and steel it is 310 to 700 MPa. And coming to the rusting, and this is one of the most important thing which we had, which has to be considered, especially in the steel structure, because rusting shouldn't happen in the structure. So as we see here, it is said that cast iron, it does not rust, and coming to the wrought iron, it rusts more than cast iron, and steel it rusts very easily. And coming to the ductile property, the cast iron is not ductile, it is brittle in nature, whereas wrought iron and steel both are ductile in nature. And coming to the weldability, when we come to steel structures, the welding and the bolted connections are all very familiar to us. So we have to see the weldability of the material which we are using. So coming to the weldability, the cast iron cannot be welded, wrought iron can be easily welded, whereas the steel which we will be using, or which we regularly use, can be rapidly welded. Okay. Now, depending upon the carbon content, actually the steels are designated as follows, which I have told here. Like low carbon content means the carbon content is about zero point 0.1 to 0.25%. Medium carbon steel is carbon content of 0.25 to 0.60, and high carbon steel is 0.60 to 1.10%. And the structural steel normally have a carbon content less than 0.6%, and increase in the have a carbon content less than 0.6%. And increasing the carbon content increases the hardness, yield strength, and ultimate strength of the steel. However, it decreases again the toughness and the ductility, as if one factor is there, there will be some other disadvantage, as we can see here is the ductility and the toughness. And mild steel has a carbon content less than about 0.1% and widely used for the structural work. Okay, so these were the properties of the steel which we have to consider in the steel structures. Now coming to the structural steel. Structural steels are the alloys of the iron containing carbon content less than about 0.25% and manganese less than 1.5%. Okay, carbon and manganese are main constituents which increase the yield strength of the steel. And here are some of the general categories which I have listed of the structural steel. Carbon steel, high strength carbon steel, medium and high strength microalloy steel, which and coming and fourth one is the fire resistant steel. It is called as TMT steel. Okay, carbon steel is the carbon and manganese are the main strengthening elements. Which is the first one, and it has a minimum tensile strength of about 380 to 450 MPa and minimum yield strength of 230 to 300 MPa. And coming to the next second one is the high strength carbon steel. It has a carbon content of 0.6 to 1.10. It has low ductility, toughness, and also weldability. And high strength carbon steel is usually used in the high transmission lines and microwave towers. And medium and high strength microalloyed steel. It has a very low carbon content and but achieves very high strength due to the addition of alloys such as niobium, vanadium, and titanium. And ultimate strength is around 450 to 590 MPa, and minimum yield strength of this medium and high strength microalloy is 300 to 450 MPa. And fire resistant steel is the TMT steel, as I have said here. It is called as thermomechanically treated steels. They perform better than the ordinary steels under fire. So now let's see about the advantages of the structural steel, which has to be studied before the design of the structure or before any introduction of any subject, as it is to be studied. Here we'll see about the structural steel. Steel offers better compressive and tensile strength than concrete. This is one of the main advantage we can say, and it is lighter, and also lighter constructions can be done using the structural steel. And steel also can be recycled, which contributes to the environmental friendly. We can call it as a green building also. When the steel structure is built and then it has to be collapsed, or it can collapse, or it has to be renovated, the remaining steel can be almost around 50% of the amount can be got back, we can say. Like as I said, it can support for the green building. And also erection is faster in the steel, in the structural steel. Prefabrication and demountability. Prefabrication, as the structural as the steel structures are being very part wise, so prefabrication of those structural steels or the structural components of the structural steel are being prefabricated at the production site, and then it is being brought to the construction site, and then just it is molded. So it is also one of the important advantage which has to be known. And also coming to the using the welding, connections using the welding, bolting and riveting also can be done using the structural steel. High ductility, which withstands the extensive deformation without failure. So now coming to the structure disadvantages of the structural steel. Coming to the disadvantage, here I have listed some of the disadvantages which the structural steel is. And it requires fire protection. That is one of the most important thing which has to be known. That is one of the important known, and requires corrosion protection. It requires corrosion protection. And in the steel buildings, the claddings and the dividings walls are made up of masonry or other materials, and tolerances specified for the steel fabrication and erection are small compared to those RCC structures. And also welding, tightening of the high strength friction grip bolts and require proper training. In many cases, cost of the steel structures work out to be more than the concrete structures. So these are the some of the advantages which are being listed here, which has to be known. And coming now, next topic is the stress strain curve for the mild steel. Mild steel. Here I have shown the specimen which is obtained from which is a standard specimen which is used for the test specimen. test specimen, and here the ultimate strength at which the steel would fail is obtained from a tension test on a standard specimen. Here the two vertical lines are there. Between these can be called as the gauge length, and LC, which has been mentioned here is the parallel length we call, and the area which is shown here, it is the original cross sectional area. And the minimum gauge length between this is the gauge length, and it should be 5.65 times the root of area. And this specimen which conforms to IS 1608, it has to be fixed to the tensile testing machine, and tested under the uniaxial tension, and the loads are applied through the threaded ends. So now coming to the stress strain curve of the mild steel. Here is the curve which is showing the stress strain curve, and it has the different types of regions which are typically four regions are there, which is the linear elastic region, plastic region, and strain hardening region, and the strain softening region, which can be also called as necking. So as we see, here we see the stress is proportional to strain till the limit of proportionality. Then the yield stress is there at the point P, and it is plastic in nature till the point C. We can see once the after this the strain hardening is achieved. Hardening is achieved from the point C to D, as we see in the graph. And once the point D is achieved, it is called as the ultimate stress. And then again the stress gets reduced, and then the fracture happens. Then the necking of the structural steel is take place. As I said, necking, it is a localized, as we saw, as it is mentioned in the part of DE, it is a necking. It is after once that is achieved, once the ultimate stress is achieved, it is a localized reduction in the area called necking, necking begins, and elongation continues with diminishing load until the specimen breaks. Okay, so this was the steel stress strain curve for the mild steel. And now coming to the mechanical properties of the steel, which have been mentioned in the table. The modulus of elasticity, it is 2 into 10 raised to 5 MPa, and shear modulus E is equal to shear modulus G, is equal to E by 2 into 1 plus mu, which is equal to 0.769 into 10 raised to 5 MPa. Coming to the Poisson's ratio, it has two different values for two ranges, that is the elastic range and the plastic range. For elastic range, it should be 0.3 and 0.5 for plastic range. And also unit mass of the steel also has to be known by the user or the designer, and unit mass of the steel is 7580 kg per meter cube. And coefficient of thermal expansion, it should be 12 into 10 raised to minus 6 per degree Celsius. Also Brinell hardness number, it is around 150 to 190, and approximate melting point of the uh, structural steel is 1530 degrees Celsius. So now coming to the structural steel products, as we know that very many different types of structural steel products are available in the market, and many different types of products are very easily available, and some are very rarely available. So that has to be known by the user or the designer before designing the structure. So here I have just listed some of the steel products which are interest to the designer, and are like categorized into the following: flat hot rolled products. The plates, flat bars, sheets, and strips are the hot rolled products, and hot rolled sections are the roll shapes and hollow structural sections. And the next is the bolts and welded electrodes and the cold rolled shapes. These are the some of the structural products which has to be used, which are being used for the structural design. You can call. Okay, now let's see about the hot rolled sections and the products. And here are many types of the hot roll sections. Here I have listed them. They are the rolled beams, channels, angle sections, and the T sections. Okay, so these are the ones which I have mentioned. For in the rolled sections, we rolled beams we have ISJB, ISLB, MB, ISWB, and HB. The abbreviations have been given here. You can just go through them. The ISJB is the junior beam, LB is the light beam, medium beams, and wide flange beams, and heavy beams. And in Indian industry, maximum of medium beams are being used. And also channels are there. I have listed them: ISJC, ISLC, ISMC, and ISSC. And coming to the angle sections are two different type, as it is mentioned: equal angle section and unequal angle sections. And coming to the T sections also there are some of the five types. ISJT, it is the junior T bar section, T bars, and ISLT is the light T bars, ISHT is the heavy flange T bars, ISNT is the Indian standard normal T bars. And next, coming to the rolled bars, it is of two: round and square. Indian standard round bars, Indian standard square bars. And also tabular sections are used: ISLT, ISMT, and ISHT. And lastly, plates, strips, and flats are also being used. And here I have shown the some of the sections which I have listed in the previous slides. You can see flat bar, angle section, round, and sheet or plate, channel section, wide flange beams, standard I sections or I beams. Like these are the some of the structural steel products or the sections which are being used in our designs. And now coming to the choice of the section, here I'm told many types of sections and many different types of products. So you have to know about the choice of the section which has to be used. So that has to be governed, and that has to be first known for the designer. Here are the some of the 5 points I can say which are being governed for this design of the steel section: cross-sectional area, section modulus, radius of gyration, availability of the section, and ease of the connection. So these are the some of the key points which govern the design of the section. Um, Coming to now in India, coming to the Indian scenario, only ISMB sections are the most commonly used products, and ISHB sections are also very limited, as they are the heavy beam sections. And also coming to the channel sections, only ISMC are being used, and limited number of unequal angles are also available in market. Hence all, and also we have to see that the all equal angles are not available in the market. Hence when we see the market scenario and what types of sections are available and not available, it is a good idea, or it is a good practice to first initially list down the types of the sections of the products available, and then design accordingly which is favorable for the scenario it has to be built with. So as I was saying earlier, that the ISMB section is the only section which is normally produced in India. These are the sections used for the beams as well as the columns, and these sections are relatively narrow and sloping flanges and a thick web compared to the wide flange section. ISMB sections are not economical, especially for the compression members, because of the excessive material of the web and the lack of the lateral stiffness due to the narrow flanges. And coming to the Coming to the features of the wide flange beams, which make them more popular for the Indian standard than the Indian standard I beams. Here I have listed some of the few points. I listed a few points. Wide flange sections are the wide flange beams have high bending and buckling resistance due to the H-shaped arrangement of the flanges and the webs. And H beams have a higher section modulus for the same weights, hence it is economical, and also around 10 to 24% of the savings can be done by using this. And there is no taper in the H beam flange, and hence no tapered washer is necessary for bolting, which reduces the fabrication difficulties. And H beams can be easily butt welded, and also gusset can be welded to the inner surface of the beam. So uh, this is the part one lecture which I dealt with the properties of the steel, structural steel, and the stress strain curve for the mild steel and the structural steel products, and the choice of the section. In the next part, we'll be discussing few more topics of the based on the introduction of the steel structure itself. Thank you.